Hi everyone, welcome back to our YouTube channel Tutorial Home My Electrical. In today's video, I will going to produce a lecture regarding quick revision of performance of transmission line of power system. If you like this video, please like, share and subscribe my channel with your friends. And if you want notification regarding my channel, please press the bell icon. Okay, so let's start today's video. In today's video, I will going to discuss the performance of transmission line. Okay, before starting performance of transmission line, if you have to remember the classification of transmission line. First is short transmission line, medium transmission lines, long transmission line. Now you have to know in what basis we classify short transmission line, medium transmission line and long transmission line. Okay, now for short transmission line, the multiplication of frequency and the length of transmission line is less than 4000 Hertz kilometer. Okay, in short transmission line, the multiplication of frequency and the length of the line is less than 4000, and the length of short transmission line is always less than 80 km, and the operating voltage of short transmission line is in between 0 and 20 kilovolt, and effect of capacitance is neglected here. For short transmission line, the effect of capacitance is neglected. Okay. Now coming to the medium transmission line. For medium transmission line, the multiplication of supply frequency and the length of the transmission line is in between 4000 and 12000. Means greater than 4000 and less than 12000 Hertz kilometer. Okay, and the length of medium transmission line is in between 80 km and 240 km. And the operating voltage of medium transmission line is 20 to 100 kilovolt, means in between 20 and 100 kilovolt. Here we assume the capacitor is lumped and constant. Means for medium transmission line, capacitor is lumped. We assume capacitor is lumped and constant. Okay. Now going to the long transmission line. For long transmission line, the multiplication of frequency and the length of the transmission line is equal to 12,000 Hertz kilometer, and the length of long transmission line is greater than 240 kilometer, and operating voltage for long transmission line is 100 kilovolt, greater than 100 kilovolt, and here we take capacitance is uniformly distributed. Means capacitor we take here for long transmission line, capacitance we take as it is. In medium transmission line, we assume capacitor is lumped and constant, but for long transmission line, we take capacitance as it is in transmission line, means uniformly distributed. Okay. Now you have to know the circuit parameter, means ABCD parameter of short transmission line. For calculating ABCD parameter, we have to draw the circuit of short transmission line. In short transmission line, sending in current IS is flow through a resistance and inductance, and we get the receiving current. By seeing that, you already know that the sending in current is equal to receiving current, because the receiving current is same as sending in current. Okay, and here is sending in voltage and here is receiving voltage. Now we got the sending in voltage by adding receiving in voltage to the voltage drop in the impedance. Line impedance, voltage drop in line impedance. By adding, we get the sending in voltage by adding receiving in voltage to the line voltage drop in impedance. Okay, so Vs equal to Vr plus IRZ. Now we have to calculate the ABCD parameter. Okay, if we calculate ABCD parameter in matrix form, we rewrite the matrix here. If we rewrite the matrix of short transmission line, then Vs Is is equal to 1 Z0 1 Vr Ir. Here A equal to 1, B equal to Z, C equal to 0 and D equal to 1. Now from here we have to know the Vs. Vs is here Vs is 1. We know the matrix Vs is equal to 1 into Vr plus Z into Ir. So this equation is satisfied. Vs equal to Vr IRZ, and Is equal to 0 into Vr means 0 plus 1 into Ir. So Is equal to Ir. This equation is also satisfied. So this equation and this equation is satisfied by this matrix. Okay. So from here we got A equal to 1, B equal to Z, C equal to 0, D equal to 1. If we see A equal to D, if we see the matrix, then we know A equal to D. Okay. So now Vs equal to Vs nearly about equal to VR plus IR, R receiving current into resistance of transmission line into cos phi plus minus IR into IR x sin phi r. Here phi r is load angle. Okay. So the in calculating voltage regulation, we have to first know the definition of voltage regulation. What is the definition of voltage regulation? In the definition of voltage regulation, the change in receiving end voltage from no load to full load. Change in receiving end voltage from no load to full load. No load to full load, keeping sending end voltage and supply frequency constant. This is important. This is very important. Keeping sending end voltage and supply frequency constant. So what is voltage regulation? Voltage regulation is change in receiving end voltage from no load to full load, keeping sending end voltage and supply frequency constant. Okay. So now we have to go to the regulation of short transmission line. So regulation of short transmission line is Vs minus Vr by Vr. Here, if we rewrite this, the regulation is Vs minus Vr by Vr into 100%. To 100%. Okay. So if I calculate this going to remain IR into R into cos phi r plus minus IR into sin IR x sin phi r divided by VR into 100%. Okay. Where plus sign, here plus sign is for lagging part vector and minus sign for leading part vector. Now the note point is very important. The note point is regulation is always positive for lagging part vector. Regulation is always positive for lagging part vector. Regulation is always positive for lagging part vector. And next is regulation may be positive, negative or zero for leading part vector. Regulation may be positive, negative and zero for leading part vector. For lagging part vector, regulation is always positive, but for leading part vector, regulation may be positive, negative or zero for leading part vector. Okay. In short transmission line, next note point is, in short transmission line, sending in part vector is always less than receiving part vector. It is important. It is important, very, very important. In short transmission line, sending in part vector is always less than receiving in part vector. Okay. Next note point is, for short transmission line is symmetrical and reciprocal. It is also important. Short transmission line is symmetrical and reciprocal. Short transmission line is symmetrical and reciprocal. Okay. Next note point is, regulation is maximum when phi r is equal to theta. Okay. Regulation is maximum when phi r equal to theta. Regulation is maximum when phi r equal to theta. It is also important. Phi r equal to theta. Where phi r is phase angle of load, and theta is impedance angle of line. It is also represent tan inverse x by r. X means inductance of transmission line and r is the resistance of transmission line. Okay, so next note point is for zero voltage regulation, for occurring zero voltage regulation, the phi r plus theta will have to equal to pi by 2, means 90 degree. For zero voltage regulation, phi r plus theta is equal to pi by 2. Where phi r is, for zero voltage regulation, phi r is tan inverse r by x. R is the resistance of transmission line and x is the inductance of transmission line. Okay, and this is also important. This is also important. This is also important. So now we have to go the medium transmission line. Okay, if I rewrite the medium transmission line in the term of ABCD parameter, in matrix form, here we discuss the medium transmission line in two types. One is nominal T circuit, and another is nominal pi circuit. T circuit and pi circuit. For T circuit, the VSIS is equal to 1 plus YZ. Y is admittance of transmission line, YZ by 2, and B is Z into 1 plus YZ by 4, and C is Y, and D is 1 plus YZ by 2 into VRIN. Okay. For nominal T circuit, A is 1 plus YZ by 2, B is Z into 1 plus YZ by 4, and C is Y, and D is 1 plus YZ by 2. Okay. Now we have to go for nominal pi circuit. For nominal pi circuit, A is 1 plus YZ by 2, B is Z, C is Y into 1 plus YZ by 4, and D is 1 plus YZ by 2. Okay. If we notice for nominal pi circuit and nominal T circuit, we identify that for nominal T circuit, A and B is equal. Also, for nominal pi circuit, A is equal to the A for nominal T circuit. Means for nominal pi circuit and T circuit, A and D is equal to 1 plus YZ by 2. So if I rewrite this for nominal T and pi, okay, A and D is 1 plus YZ by 2. Okay, A and D is 1 plus YZ by 2 for nominal T and pi also. So now we have to go into the note point regarding medium transmission line. Okay, for fixed receiving end voltage, means if receiving end voltage is constant, then sending end voltage, which is calculated in nominal pi method, will be slightly higher when compared to nominal T circuit. For the receiving end voltage is constant, for a fixed receiving end voltage, the sending end voltage, which is calculated in nominal pi method, will be slightly higher when compared to nominal T circuit. Okay, means sending end voltage in pi model is slightly higher compared to nominal T circuit. Okay, and also, so regulation in nominal pi circuit is slightly high when compared to nominal T. Means slightly higher in nominal pi method. Means voltage regulation in nominal pi method is slightly higher than nominal T circuit. Means for fixed receiving end voltage, sending end voltage in nominal pi method is slightly higher when compared to nominal T circuit. So voltage regulation in nominal pi is slightly high when compared to nominal T circuit. Okay. So in this video, I have completed the short transmission line and medium transmission line. I have to discuss the long transmission line in next part. If you want notification regarding next part, please press the notification bell. Thank you. Keep preparing. Thank you again. Keep preparing. Okay. So we will come back in next video, next part. Okay. Thank you.